Hey, so let's go ahead and review some mole conversions, and in this video we're going to look at moles, grams, atoms, and molecules. You'll want a piece of paper and a calculator or something to practice with. I'll have you pause the video once I show the question. You can try and start it yourself, answer it, and then I'll go through and answer it with you. Okay, so here goes. First, we're going to convert 23 grams of sodium chloride into moles. Okay, so you know that the first step in all of these problems is to find the molar mass of the compound that you're working with. So first thing, we're going to take NaCl, and we're going to look at the periodic table and figure out what 1 mole of each of those atoms weighs. For Na, I know that it's 23. For Cl, I know that it's 35.5. And we'll go ahead and add those up. I know that this is terrible handwriting. And that is 58.5, and the units for that are grams per mole. Okay, so that will be our conversion factor. You get to decide between the two of these which ones we're going to use. So you can either have it like we just wrote it as 58.5 grams over moles, or you can write it as 1 mole over 58.5 grams. So the way that you pick between those two is that you want to be able to cancel grams. So here's our first step. You're going to write down, after you've done that, you're going to write down 23 grams of NaCl, and you always put that over 1, and then we're going to multiply by the conversion factor. So you are picking here, and I'll highlight them again if I can, between that and blue, or this and red. So which one are you going to choose? The red is correct, because you want grams to cancel. So we'll go ahead and punch that in. Why don't you calculate that and tell me what you get? You got 0.39 mole. That is your final answer. Well done. And you have done your first problem. Congrats. Okay, so now on to the next one. We're going to convert, this time, 2.3 moles of aluminum into atoms. So we will go ahead and write, for our first step, 2.3 mole of aluminum, put it over 1, and we're going to convert that into atoms. So what you need to do for all of these is look and see, okay, is the molecular compound that I'm using, is it something that's by itself, like an atom, or is a molecule, like for example NH3, that is a group of atoms? So what do you think here? I say atom. So in this case, when you convert to moles, you're going to divide by 1 mole because you want moles to cancel. And this is a counting thing. We're trying to figure out how many atoms fit in 1 mole. So we're going to do 6.02 times 10 to the 23rd. And in this case, we can convert directly to atoms because aluminum is not a molecule, it is an atom. So you can punch that into your calculator. 2.3 times 6.02 times 10 to the 23rd. If we look here, our moles will cancel in blue. And when you do that, you should get the following. $1.39 times 10 to the 24th. And that unit is atoms. Okay? Okay, so in our next one, we're going to convert 4.5 grams of calcium nitrate into atoms of nitrogen. Okay, so first off, the last problem, what we were working with only had 1 atom, and here you can tell that you're working with a molecule because it's a group of atoms. So we're going to have one extra step onto the last problem. Our first thing that we need to do is figure out the molar mass. So let's go ahead and do that. Calcium nitrate, you're going to be adding up 40 from calcium, 40 grams plus 14 times 2 from each nitrogen, plus 16 from oxygen, and that's going to be multiplied by 6 because you've got 6 oxygen. When you add all of that up, you should get 164, and the units will be grams per mole. Okay? Like earlier, you're going to take that conversion factor and actually flip it so that you can cancel your 4.5 grams out. So let's get started with that. 4.5 grams, you put that over 1, and you're going to go ahead and multiply. We said we're going to flip the conversion factor over so that grams goes in the denominator and cancels out. And I will go ahead and show that. Canceling. There you go. So that gives us moles. And I'm going to show you how to do this problem in multiple steps. So if you wanted to stop here, you could put an equal sign, you could figure out the moles, and then you can move forward. I'm going to say, okay, we are good. We now have moles, so let's go ahead and cancel it out and do this all in one equation rather than splitting it up into several ones. I don't care which way you do it. Both will get you the right answer. So I know that moles needs to now be in the bottom, and we're working toward counting. We're working toward trying to figure out, okay, how many of these things actually comes in 1 mole, or in this case, 4.5 grams. So we know that 1 mole, according to Avogadro, has 6.02 times 10 to the 23rd particles. And we know in this case that particles is talking about molecules that we used earlier. Okay? So if I multiply that through, that should give me molecules, right? Because moles will cancel. And then if you look up top, each molecule of calcium nitrate has how many atoms of nitrogen? It's got 2. So I'll go ahead and multiply. I'll put 1 molecule in the denominator. Again, sorry for my terrible handwriting. And 2 atoms in the numerator. And then molecules will cancel. When you multiply that all the way through, you should get 3.3 times 10 to the 22nd, and the unit will be atoms of nitrogen. Okay? Awesome. Okay, and for this portion, we're going to go ahead and take this problem where we convert 3.4 times 10 to the 31st molecules of CO2 into grams. That's going to be the exact reverse of what we just did. Okay, so we're going to start with molecules. 3.4 times 10 to the 31st. That's over 1, and the unit is molecules. And we're working with CO2, right? Because that's multiple atoms, so it's a molecule. We want molecules to cancel, and we want to get to moles, because you're always trying to get to moles in the middle. Remember that mole map that we've used in class. So in 1 mole here, we're going to take 6.02 times 10 to the 23rd. And I know that in each mole there are that many molecules. Okay? If I multiply that through, that will allow me to cancel molecules, which is great. And actually, I want to be able to do this all at once. So what I'm going to do is go ahead and multiply here in blue by the molar mass of CO2, which I calculated from the table, is 44 grams for 1 mole. That will let me cancel out moles, which is great. And if I multiply the top, divide by the bottom, if you're plugging that into your calculator, make sure you put parentheses around the 6.02 times 10 to the 23rd like I just showed. And then if you punch that in, you should get this. 2.4 times 10 to the 9th grams. That's a G. Okay, and let's finish with an easy one, just as a review. If I am taking 123 grams of C6H12O6, which is glucose, and I want to find moles, I need to go ahead and add up the molar mass. So I already did that. That's going to be 100 and what I have, 180 grams for every 1 mole. That's the molar mass of glucose. You're going to decide between these two conversion factors. So if you're getting tripped up earlier, I wasn't showing this step where you picked. You can go ahead and choose which way you want to write this so that grams will cancel. Okay? Whatever number I give you in the problem to start, that's the one that you start with and put over 1. So I'm going to go ahead and write 123 grams, put that over 1, and then we're going to multiply by one of those two conversion factors, either the red or the blue. I'm going to actually end up using the one that's in the blue because I want grams to cancel and to end up with moles. So I'll show grams canceling when I multiply that through. That's going to give me 0.68, and my units will be mole. Okay, so thanks for watching. Go back through and practice if I went too quickly, or pause it. Make sure that you know how to do these because it just builds and gets trickier from here. Okay, thanks. Have a great one.